Hello. Thanks for having me. And persistent debate in affective neurosciences is whether we represent emotions as categories or dimensions. For example, when we see the face of someone or when we hear the voice, do we automatically identify the emotion as a distinct category? Is it surprise, anger, disgust, and so on and so forth? Or do we evaluate the expressed emotion as along continuous dimensions, such as valence from a negative to positive, or arousal, the intensity of the expressed emotion? And this question is continuing to generate paper after paper in prestigious journals, empirical studies, commentaries on the empirical studies, meta-analysis, even this nice and quite entertaining survey by Ekman, who actually went to the length to ask scientists, try to find out what affect scientists agree about. And one possibility is that there might be discrepancies because people measure the representation of emotions using different variables: behavior, fMRI, MEG, and so on. What we did was to investigate the representation of perceived emotions expressed in voice. We investigated representation focusing on three variables: perceived dissimilarity, fMRI, and MEG, cerebral responses, high spatial and temporal resolution. We were interested in converging evidence. What is common what is common between all of these measurements about what they tell us about the representation of emotions. More importantly, we were interested in detailing a missing piece of the puzzle. We know when emotions are represented, we know where, but we do not detail simultaneously both, which is we lack a view of the detailed view of the spatio-temporal dynamics of emotion representation. Our stimulus set started from 5 voices for each of 2 speakers selected from the Montreal Affected Voices database, 4 emotions: anger, pleasure, fear, and disgust, and a neutral expression. You will hear some examples. And we use morphing to interpolate between these 5 recordings. And so we interpolated between emotions. And we also interpolated from neutral to each of the emotions, so we increased the intensity up to the point where we even had, we extrapolated to have a hyper anger or an hyper fear. And what I'm showing here instead is the categorization response that we recorded for the continuum, morphing continuum, from anger to disgust to pleasure. And let's hear first the female speaker. Okay, it works quite well, eh? Then pleasure is hard. Anyway, so 10 poor participants had to listen repeatedly to these voices during 11 sessions each. So they went through first 8 imaging sessions, fMRI, MEG alternated. The task was independent of emotion, 1 back repetition detection. They evaluated then the perceived dissimilarity. We did not tell them how to evaluate behavioral session. The dissimilarity of the stimuli, we were interested in what they would have considered among the emotion attributes when carrying out this task. And only during the last session they carried out tasks to evaluate their perception of the categories and dimensional attributes, rating tasks. We use representational similarity analysis. In a nutshell, representational similarity analysis is about comparing how diverse the brain distances to our stimuli are with how diverse they are according to a given model. So we were interested in comparing the dissimilarity or distance of brain responses, fMRI and MEG separately we did to the different stimuli, with distances of the perceived emotions. And we beamformed the MEG, so it was we did this in a searchlight, and we actually mapped each brain to its own participant, and then carried out group average RFX inference. Some technicalities, there are obvious correlations. We did our homework. We measured the representation independently of the shared variance between these models, basically. We contrasted the categories versus dimensions. We also took care of getting rid of what in the cerebral and perceptual responses was explained by acoustics. We did this for perception and MEG. fMRI, not yet, but I feel we might have to do it. And we constrained the MEG analysis within a mild fMRI mask of non-selective representation, because we were interested in converging evidence. Acoustics, perceptual dissimilarity at onset, very strongly influenced by acoustics. It's the modulation transfer function. Sorry, I forgot to mention. It's a very popular model nowadays of the computational model of the cortical response to complex sound stimuli by Shamma, great model. And spatiotemporal modulations were represented, as expected, in the bilateral temporal cortex at around sound onset, well, quite later, but at the beginning. Let's take a look at the behavioral data. So, what I'm showing here, up here, is the perceived dissimilarity, average across speakers and participants. This, instead, is the distance of the categorizations, and these are the distances of the arousal and balance responses. So what we asked was whether this perceived dissimilarity resembled any of these, and which of the emotion attributes drove the perceived dissimilarity. Well, there is a much needle statistic. What we found was that when people evaluate the perceived dissimilarity in the absence of explicit biases about what to focus on, they focus strongly on categories, and then they consider a little bit arousal. But anyway, categories drive dissimilarity much more strongly than dimensions. The MEG results showed us that categories are represented early, from 157 to around 400 milliseconds, in the bilateral temporal cortex, extending to the left inferior frontal cortex. And dimensions, instead, have a quite different evolution, let's say. And they are represented, of course, the temporal cortex. This is all independent of the modulation transfer function. The temporal cortex is represented in the bilateral temporal cortex. Dimensions are still represented in the bilateral temporal cortex. But the regions, the network extends, for example, to interesting structures such as the amygdala in the limbic system or the insula. And this comes late. Like, there is some representation at 237 milliseconds. Sorry, I forgot to mention the sound is 800 milliseconds long. And, but it peaks, this representation of dimensions, quite late. We asked then what drove the cerebral responses. Which of the two categories or dimensions drives more the cerebral responses? And we found in both fMRI and MEG that categories, again, drive more strongly the right temporal cortex, the MSTG, whereas at a later point, consistent with what I showed before, dimensions dominate. And, you know, it's the same area. It's bilateral here, but it's the same area that switches from a category representation to a dimension representation, which is quite interesting to me. And so, to summarize, we found that both categories and dimensions account for perceived dissimilarity, fMRI, and imaging responses. This is not news. We found that categories dominate perceptual and early cerebral representations. We can, speculate, this is going to help behavior with fast adaptive reactions. But what is interesting here is that the representational dynamics, we found a different, distinct representational dynamics for the two. So what we are starting to think is that what matters is not which of these models wins, but where and when each is represented. And I would like to thank all of the collaborators and BBSRC who paid for all of this coming. Thank you.
We have time for one question.
I have a question. I have a question if anyone, okay, great. So, darn, no, okay, all right. So I'm kind of curious about whether, so a big part of this debate is about where those categories come from and whether they're more or less innate or whether they're more or less acquired. And I guess I'm kind of wondering, if you were to perform a parallel study where you just took 5 features of acoustics and created categories and morphs, they didn't have to sort of fit the ones that we hear here. Do you think that you'd find something similar with that much training, like so many sessions that basically they're acquired categories, which could still explain a basic emotions view? Or
you mean whether we would find the same temporal dynamics pattern, the precedence of... I cannot say, really. I really cannot say.
Maybe another way of asking is it possible that early on, were the responses stationary across the runs? So in early runs, did you see basically the same kind of findings as in later runs, or did it change and become earlier?
I did not analyze the change across runs. What I can tell you, which is interesting, is that if we did not remove acoustics, it's just another thing, we would have found much earlier category representation, around 70 milliseconds. But
interesting.
So acoustics accounted for super early representation, which is acoustics is important for the perception of emotions. I have to say, that's my opinion.
Thank you.
Thank you.